Hello and welcome to TypeScript, JavaScript Evolved. My name is Jess Chadwick. I'm going to be walking through TypeScript with you today, and my email address is jesschadwick@gmail.com. Feel free to send me an email if you have any questions or comments, or my Twitter handle @jchadwick. I'm an author of various magazine articles, books, and some online training courses at lynda.com. Look for the full TypeScript course over there soon. I'm also an ASP insider, but most importantly, I'm a coder. I'm also the host of the Static Void podcast. You can check us out at www.staticvoidpodcast.com. But we're not here to talk about me today. We're here to talk about TypeScript. So first and foremost, what is TypeScript? TypeScript is a superset of JavaScript. It's just JavaScript, right? It's JavaScript with a whole bunch of other cool stuff on top of it. And so we can see on the right-hand side, I've got these kind of concentric circles going out. What is JavaScript? JavaScript, as we know it, has had some kind of various names. A couple of them, ECMAScript 5, right? So ECMAScript 5, I'm recording this in November of 2015. ECMAScript 6, the specification, ECMAScript 6 specification was ratified over the summer of 2015, but what is still widely available, widely implemented in the browsers today is ECMAScript 5. So ECMAScript 5, ECMAScript 6, these are specifications, JavaScript specifications that kind of define the APIs and everything that we'll see in JavaScript. ECMAScript 5 being around for a long time now, and so it's widely implemented. But just because ECMAScript 6 was ratified over the summer, the specification was approved and ratified, doesn't mean it's actually available in all the browsers. And in fact, it's not really available in a lot of places, right? All of these specifications are not widely available in browsers today. Again, November 2015. If you're watching this in 2016, that might be different, right? We're probably going to have a lot more support. But what TypeScript allows us to do is write with ECMAScript 6 today, the fully specified, this fully ratified specification, and transpile or compile down to ES6 or ES5. So we can write in ES6 today, we can transpile down to ES5, so in other words, generate JavaScript code that will run in an ES5 browser. Everything will run fine. Once the browsers start understanding ECMAScript 6, the ECMAScript 6 specification, then we can just stop transpiling to ECMAScript 5, start targeting ECMAScript 6, and just run our code as it is. What TypeScript also allows us to do is leverage some future features like ECMAScript 7, in other words, the next version of JavaScript or the ECMAScript standard. And then the final kind of circle outside is types. So TypeScript, meaning types, adding typing to our application. So traditionally, JavaScript has it's been a dynamic language, still is, right? JavaScript is a dynamic language, meaning that you can create variables of any type, and you can even kind of change types, right? So you can create a variable that has a number in it, and then just kind of reassign that variable to a string variable or a string value, and everything's fine, right? But what strong typing allows you to do, the benefits of strong typing, allows you to kind of specify a specific type for that variable and say, this variable is a number, and if I try and use it as anything else, I'm going to get some errors. So at compile time versus runtime, I can actually catch those errors, and the compiler will tell me, well, you said this was a number, but now you tried using it as a string, or you tried assigning it to a string. That's not cool. That's not going to work. The compiler will tell you before your code even gets off of your machine, that's not going to work, right? You also get some better tooling. So you get some refactoring, autocomplete, etc. And this helps you avoid several classes of errors for free. What do I mean by that? Things like spelling errors or something, right? And so I hear this all depends on the tooling that you have today. So some tooling is better than others. You have the WebStorm editor, you have Sublime Text, you have all these kind of editors that you can work with JavaScript in, and many of them have different levels of tooling. So most editors today will have some form of autocomplete. Autocomplete meaning, here are all of the parameters, or here are all the properties or method names in any JavaScript class or any JavaScript function that you've defined in your entire application. Do you want to use one of these 1,000 property names or method names? That's autocomplete. That's the autocomplete you get. So that can be pretty helpful. But what strong typing allows you to do is that it says, okay, you've defined this class, and this class has these 3 methods. And so when you go to autocomplete, it's just going to allow you to autocomplete on one of those 3 methods. So it gives you very specific autocomplete. By tying those methods and property names, field names, and everything to a specific type, you also get better refactoring support. So again, if I want to go back and rename a property called first name on one of my classes, on one of my types, if I do that in JavaScript, with a tool that supports refactoring JavaScript, that tool will say, okay, you want to rename the property name first name? Here are all the references to the name first name that I see in your application. And that's the best it can do because of the dynamic nature of JavaScript. It doesn't really know whether that first name property or that first name variable or whatever is this first name that you're talking about on this type, right? Versus when you create a type and you say this type has this property called first name, and then I go to refactor that, it's only going to find instances or references of that type, and specifically that property on that type, that first name property on that type, and just rename those references and leave all the other ones alone. So that helps you give better refactoring and all of those things. Strong typing also allows you to explicitly express intent. So this allows you to write code for humans and not computers. It allows you to say, this variable is a string. There's no doubt about it. My intention is that this is a string. It always will be a string. Don't try and use it as anything else, right? And so the dynamic nature of JavaScript allows you to do lots of cool things, right? So when I first learned about TypeScript and applying types and strong typing to JavaScript, my reaction, I just freaked out, right? You want to do what to my JavaScript? You want to take away that dynamic nature of JavaScript, but that's not really what we're doing here. We're actually adding typing to the dynamic nature of JavaScript. We're keeping that dynamic nature. We're just adding typing. And you can actually tell TypeScript to butt out, right? You can start applying typing. And here's a little sneak peek of how you apply typing, right? So I've got var x, and I'm giving it the type of number. I'm saying x, this variable x, is the type number. And I'm even assigning it to a value, 3, right there. And on the very next line, I'm going and I'm saying, here's another variable y. This variable is of type string, and I'm going to assign it to the value of x. But they're 2 different types, so TypeScript is going to give me an error. Let's say that that's what I want to do. It's not really what I want to do. It doesn't really make sense, but let's say I want it to do it. We can define it as the any type. In other words, we can tell TypeScript this is the dynamic type. The type of this variable can be anything, including switching back and forth between string, number, whatever, and basically fall back to the dynamic nature of JavaScript. So with this, you can still take advantage of dynamic JavaScript, but also allow typing or enforce typing whenever you want to. So that's one cool thing. So that's a way to kind of get into TypeScript gradually. The other cool feature of TypeScript is that TypeScript has what's called type inference. That means that TypeScript can provide typing value without you having to specify types at all. So one of my favorite features, or it's not even really a feature, but the cool things about TypeScript is it's very easy to start getting into. But basically the migration path is just convert your .js files to .ts and start compiling them and see what happens. And in a lot of cases, it's not that simple, but in many cases, it is that simple. And even just working with pure JavaScript, without taking advantage of any of that typing or anything that I just showed, and I will show more of, obviously, without taking advantage of any of that typing functionality, you can actually start getting a lot of the benefits of TypeScript, that autocomplete and the refactoring and everything, just through this type inference, where TypeScript will actually look through your code and say, oh, this function returns a number. It returns a variable that is of a type number. And so when I call that function from somewhere else, I know that that return type is going to be a number. And when I call that from blah, 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 and it can just kind of go on from there, right? And so without doing anything at all, without specifying any types at all, TypeScript can go in and it can look just by seeing your code, and it can kind of figure out. It's smart enough to kind of figure out some of these types. So this will all become a little bit more obvious later. I'll get into this later. The next cool thing is that you can have object-oriented JavaScript. So kinda, right? So you can add orientation to JavaScript. You can add object-oriented features and concept to JavaScript. But remember, it's still just JavaScript. This is syntactic sugar that we're adding on top of JavaScript, right? So it's still a prototypical language, prototypical inheritance, right? So we can define classes. We can have those classes derive from other class or implement other classes and add that inheritance. But we're still just doing prototypical inheritance. It's still just JavaScript. And if you don't understand what I'm talking about, if the term prototypical inheritance is kind of foreign to you, I really heavily encourage you to go and learn true JavaScript prototypical inheritance and all of those concepts, closures and all of that stuff. Because TypeScript is still just JavaScript, all of those concepts, all of those core fundamental JavaScript concepts still apply when you're working with TypeScript. So here's a little slide I like to call TypeScript in one slide. This is everything you need to know to get started with TypeScript. This is not everything that TypeScript offers, not hardly. As of this recording, we're up to TypeScript version 1.5 with 1.6 coming out, and they're adding all kinds of cool new features. But as a developer just getting started with TypeScript, these are the things that I'm going to kind of go over in this video, and these are the things that you want to know just kind of getting started, right? So we start out with, here's this. We got a class, right? Let's skip the interface. We'll come back for a little bit, right? We've got a class animal. Right, so we're defining an animal, and this class has a private field named _name. And as I showed earlier, we're giving that name a type. We're using the colon, and we're saying this field name is a string. And notice how we're calling it a private field. So again, it's just JavaScript. Keep that in mind. It's just JavaScript. So JavaScript, especially the prototypical inheritance of JavaScript, it doesn't offer any ability to give private fields, to define private fields or define privacy. In other words, when I define a field and I create an instance of this object, if I really want to, I can go to the console or some other JavaScript class or something like that, and I can say, new animal dot _name, and I would have access to that. So by saying private here, I'm not actually providing access. I'm not denying access in the code. What I'm doing here is I'm telling TypeScript that I intend for this to be a private field. So first of all, don't ever show it in any of the autocomplete options, right? Any of that IntelliSense or anything. And if I try to use it, if I try to access it directly, if I try to say animal dot _name equals or whatever, yell at me, right? That's a compile time error, right? So it won't actually actively stop me from using it, but it will show an error. It'll give me an error. Next, you can see I'm also saying, so I'm defining my type here. This string, it's a type of string, and I'm also on the same exact line as I define this variable and give it a type, I'm also setting its initial value. So I'm setting it to a string value here. Next up, I've got get and set, right? Get name with a method parameter, and this returns a string. So we see this is how I define a method, and it returns a string, and I'm returning this dot _name, right? Very simple, straightforward JavaScript here. So, and then I've got a setter. This get and set, this is actually an ECMAScript 5 or ECMAScript 6. It's an ECMAScript 6 feature, getters and setters. So this actually is not specific to TypeScript. You can implement this in ECMAScript 6. Again, most browsers at this point, November 2015, they don't actually support getters and setters. So you're going to use TypeScript to kind of transpile this code down to something that is compatible with ECMAScript 5 and most browsers today. But this is just ECMAScript 6 syntax. Same thing with the class, this class syntax. Not this implements iAnimal. We'll get back to that in a minute. But just class animal, ECMAScript 6 syntax. Same thing with this constructor. So we see here we have a constructor, right? And this constructor ECMAScript syntax, takes in a parameter, and I'm saying that this parameter is of type string. So if you try to pass me in a number or something else, I'm going to yell at you. I'm not going to allow you to do that. And then here, just assigning that field here. Next, we've got a method down here. This is a method definition. So you can see this is kind of in my class. I'm defining a method. I don't have to say function, but it is a function. This method happens to not take any parameters, but as you see up here in this setter and the constructor, your methods can take parameters, and those parameters can have types, just like JavaScript parameters. And in here, I'm just calling console.log, and I'm doing some string interpolation. So this is a new feature, again, an ECMAScript 6 feature that's implemented in TypeScript. But an ECMAScript 6 feature that allows me to basically run or execute some arbitrary code within a string. So I do this by doing the backticks, right? Making a string with backticks, and then using this $, open bracket and close bracket, and everything within this bracket is the code that I want to execute, and then I evaluate the output of that, and I render that string in there. So what this translates to, this is just some syntactic sugar, right? What this translates to is my name is plus this dot name plus, whatever, end of string. So it's a pretty nice little syntactic sugar that makes your code a little bit cleaner. All right, so before we leave this side, let's jump back up to the interface, right? So we can see that this animal, this class, implements an interface of iAnimal. And I've defined that interface up here. I define it by using the keyword interface iAnimal. And then in this interface, I just define some fields, right? If you're familiar with any other strongly typed language like Java or C# or even C++, these concepts should be familiar, right? You're basically just defining the structure, the contract of this interface. So here I'm just saying it's going to have a field, and that field is going to be called name, and it's going to be a string. And I'm implementing this name with a getter and setter, so it satisfies the interface. And then I also have a method, sayName, with a return type of void. So here I'm explicitly saying that the return type is void. Down here I'm implementing this interface, and I have a name that I've implemented via a getter and a setter. And I'm implementing the method. I'm not specifically saying :void. I'm not saying the return type of this method is void because I don't have to. TypeScript just infers that for me. That's fine. I don't have to specify it. So this satisfies that contract. It implements that interface. When I generate this code, when I transpile this code into JavaScript, whether it's ECMAScript 6 or ECMAScript 5, all of this interface is going to be completely removed. It's not going to be generated in my final JavaScript. It's not going to be a commented code or anything like that. It's just going to be removed. Same thing with this implements iAnimal, removed. Same thing with all of this extra typing information will just be stripped out. After TypeScript is done with it during the compilation, it uses it during compilation. After compilation, it just strips it out and it just outputs regular old JavaScript. So let's jump over to the right-hand side. So we've got our animal, right? We've got our class that defines animal. And over here, I've got a module. So a module that I've called TypeScript demo. So if you're familiar with Java or C# or VB.NET or any of these more recent static typing languages, most of them have some concept of namespaces. Right? So namespaces kind of take things out of the global namespace. So in other words, this animal, this class, and this interface, these are all defined in the global namespace. And that's generally a bad practice, to kind of clutter your global namespace with various types and instances of variables and everything. So it's nicer to kind of, just for organization purposes, to get everything out of that global namespace and put it in its own namespace. And that's what modules help us to do. So modules basically define an object, essentially, is what it boils down to. So when this gets generated into JavaScript code, this is just going to define an object called TypeScript demo, and then that object is going to have a class definition, a class called dog on top of it. And so within this module, in order to have something that actually is accessible from the outside world. In other words, down here you can see where I'm using it. I'm saying new TypeScript demo.dog, right? So this is the module name and then the class name. In order to actually expose it outside of the module, I have to call the export. I have to apply the export keyword. So I'm saying export my class dog outside of this module. And dog is extending animal. So these are very object-oriented terms, right? So animal, as you recall, is a class over here that implements an interface, the interface iAnimal, implements iAnimal, and then dog extends animal, it derives from it. So here you get your inheritance. And so what that means is that it gets all of the behavior of animal, it gets the name, it gets the say name method, and I'm also adding another method called bark. Again, no properties here, or no parameters, and no return type. In other words, a void return type. And all this does is says console.log wolf, right? Just logs wolf out to the console. So now down here in my TypeScript file, and you can see these are two different files, that's why they're side by side. So I've got animal ts over here, dog ts over here. In dog.ts, I'm actually just writing some JavaScript. So I've defined my module, I've defined my class, and I just start using them. So I define a new variable called animal, and that's of type iAnimal, in other words, this interface. So as long as it satisfies this interface, I'm happy. And then I create a new instance of the TypeScript demo.dog, and this is just pure JavaScript, right? Other than the fact that I use the module keyword and that syntax to create the TypeScript demo module, this variable basically, to get this out of the global scope, this line is still just plain JavaScript. And so I pass in the name, I call dog, TypeScript demo, new TypeScript demo dog, and I pass in a name. So where's that coming from? I didn't define that on here. I didn't define that constructor. This is actually inheriting this constructor, the base constructor, the constructor from animal. It's actually inheriting this constructor. So I can add more constructors on here, but if I don't do that, it will just inherit the base one. So unlike languages like C#, where often you have to kind of very explicitly expose constructors even in the derived classes, since this is dynamic, since this is JavaScript, I get this constructor from my base class, the class that I extended. And so here you can see, now I actually go ahead and just start interacting with it. I say animal.sayName, right? So I call the sayName class on the animal, because actually on the iAnimal, right? And then here, since animal is of type iAnimal, I can't just say .bark, right? TypeScript won't let me do that. It'll let me say sayName, because that's on the iAnimal interface. But since I know this is a dog, I can actually cast this. And I cast it using this syntax, right? I cast it using the bracket syntax, much like the C# syntax for casting. And I have to wrap that in some and I have to wrap that in some parentheses here just to kind of escape it. But once I do all that, I can say dot. And this happens to be a screenshot of Visual Studio, the Visual Studio IDE. But Visual Studio, Sublime Text, Visual Studio Code, most of these editors that support TypeScript will give you this kind of IntelliSense. And so once I say dot and I get this IntelliSense, you can see, unlike some other JavaScript tooling that I was talking about earlier, where you get thousands of options, hundreds of options that say, oh yeah, you use this somewhere else on an object, right? You use the first name property, so maybe I'll add that to the list. No, this says, I know that this is a dog, and dogs can bark. They have a name property, and they can say name. And those are the only things you can do, because they were defined on iAnimal and they were defined on dog. And that's all you can do, right? So I get a dot, and then I can kind of get in here, and I even get IntelliSense on here. So I can see that the bark method has no parameters, and it returns a void, and I can start using it. So that is TypeScript in one slide. Enough talk. Let's code. Let me show you a real live example. And for this, you can follow along. I have all this code up on the GitHub repository, github.com/jchadwick/TypeScript intro. So in that repository, we've got I've got an overview here. I've actually got a link to the slides. I've got my contact information and everything. And in here, in the source folder, we've got this very simple to-do application. So this happens to be an AngularJS application. But if you don't know AngularJS, that does not matter at all. So if I go through here, you'll see some references to AngularJS, but this is a TypeScript demo, right? So if you don't know AngularJS, that's fine. That's just what I'm using for my demo. So I've actually got my demo locally. I've got it set up locally here. And so I'll go ahead and just run the live server. I've installed this previously. I'm going to open it up in a web server just so you can see it real quick. I'll open up the application. You can see it's a very simple application. I'll open up the console and I can add a new task. Hit enter. I can remove a task, and I can click clear completed to clear all the completed tasks. But you can see I've actually added a couple bugs in this code base. So this is one of them. As you'll see later, I'm getting an error here. To-do service.clearComplete is not a function. That's because it's supposed to be clear completed. And you'll get to that. We'll get to that in a minute. You'll see what I mean there. But let's look through this code real quick. Right? So you saw that error there. Well, so here's the index.html. All right, so it's just very simple Angular application. I've got a to-do list here. I'm using Angular to create this. I've got add to do. I've got my clear completed button, and I'm wiring it all up down here, right? So I'm live linking to AngularJS, and then I'm just linking to my my JS classes, right? Very, very simple. So what do my JS classes look like? Let's start with that to-do service. That to-do service, I start out with a static ID. In other words, I have this function, right? I define this function, and on the function itself, I'm defining this property, this field, and I'm initializing it to 0. And what this effectively means is that since to-do service is a function, it's a global function, I'm creating this field once for the whole window. So I'm effectively creating a static property, a static field that I can access. And I'm just using the underscore convention just to say that this is a static private field, but obviously there's nothing protecting anybody else from changing it. It's just other than this convention that I'm using, the underscore convention. So then in here, I'm just following traditional JavaScript implementation, right? And this is my constructor function, basically. So when I want to create a new instance of a to-do service, I just go ahead and call this function, and what it's going to do is it's going to initialize itself. It's going to create a field on itself, this dot to-dos. It's going to create a field on itself called to-dos, and it's going to initialize it with an array of to-dos. What are to-dos? Well, they're just objects, right? They're objects that I know have three properties: ID, and this property is a number, right? Name, and completed. So since this is JavaScript, I can't enforce that ID is always going to be a number, and that name is going to be a string, and completed is going to be a Boolean value. But I know that they always will be, right? So already we can kind of see where some of that strong typing or static typing that TypeScript is going to provide is actually going to help us, is going to come into play, because the name, I never want it to be anything other than a string. And if I ever try to interact with it as something other than a string, I want that to be an error. I want something to tell me, no, this is a string, don't do that, right? Don't try and turn it into a number or turn it into a Boolean. Same thing with the completed, the Boolean value, and the ID, the number, right? So if I start changing any of these things, my app might start behaving in different ways, in unexpected ways. I might come up with some weird bugs if my name all of a sudden is a number and I start doing string functions on it. I'm going to start coming up with some weird bugs, and I'm not going to know why or how those things changed, right? So this is where I'm going to employ some strong typing, static typing, to help me out with that. Eventually, when I start adding TypeScript. Right here, it's still JavaScript. So let's scroll down a little bit more. And here I'm using prototypical inheritance or object orientation to add some methods to my prototype. So I'm using the prototype object to add various methods on here. So I'm adding an add function, right? And I'm assigning it to, I'm creating a new function called add that takes in a property or a parameter called to do. And this one is interesting because I'm actually accepting two different types. So this is one of those great examples of where I'm using JavaScript's dynamic nature to say, here's a to-do parameter. I don't know what it is, right? It could be anything. I'm going to look at it, right? First, I'm just going to assign it to my name, which is dangerous. As I mentioned before, I really expect my name to be a type. But basically what I'm saying here is I'm just going to assume that the to-do parameter is a string, right? And then I'm actually going to check it. So here I'm just doing equals object, right? Just make sure it's an object. I could be doing more advanced type checking or whatever just to really make sure it's either a string or an object. But basically what I'm saying is either it's a string or it's an object, a to-do object. And if it's an object, then just override this new to-do, right? This instance, override it with the object that came in. Just assume it is a to-do object. And further, assume or imply that it has a name property, right? Or a name value. And then I go on, I continue on just interacting with it normally, right? Basically, I say, regardless of whether it came in from the outside or whether it was a string or whatever, assign the ID and increment it, right? So increment this ID. So take that global, that static I underscore ID property, add one to it, and set that as my ID, that unique ID for this to-do instance, and then set completed as false, right? So just always set it as false. I can't add a completed to-do item to my application. And then finally, just use the JavaScript array function push and push the new to-do onto the array. So again, this is not TypeScript. Again, I mean, this works right here. So it's just JavaScript. So I'm pushing this item onto the to-dos array. So here we're saying this.todos, because I'm using the prototype and I'm adding this method to the prototype, it becomes a method, which means that this refers to the instance of the to-dos service that's created with this constructor, right? So again, I'm just describing JavaScript prototype and object orientation here. When I create a new instance of the to-do service, it calls this constructor function and it adds all of it attaches basically or references all of these methods that I'm defining on the prototype. They're all available from this instance. And within each of these methods, this will refer to that instance that's created. If you did not understand what I just mentioned, that description of prototype, I would strongly encourage you to just pause this video right now, go check out some other references on JavaScript prototypes, and come back and check this out because that'll really help you. So once you've got that, we can scroll down here and we see, I'm going to come back to this a little bit later, but here's another common pattern as well. Here I've got a closure. In other words, I've got a function. And in this function, I'm referring to a variable that is defined outside of that function. That's a closure, right? And so because I'm referring to this, or this.todos, I need to get a reference to this, in other words, the instance of the to-do service, before I call into this function. Because if I were just to do this without the underscore, it would not work. It would not work because of the nature of this. If you don't know why it doesn't work, again, I would go learn about closures and the problems they can have. But in order to get around this, this is a very common pattern to say, you know, self equals this, or me equals this, or whatever, right? And then so then you have a reference to yourself that then you can then pass in and reference in this closure so that it works. TypeScript will help us with this as well. I'll get back to that in a little bit. And then finally, going on, we just have some basic methods here. Get all just returns the list of to-dos, right? Remove just goes and finds them. It calls this find function. So here I've got this, again, private, in quotes, a private function, but not really. It's private just because I've given the underscore convention. In other words, it's not private at all. If some other component on my page wanted to go and call this, and it got an instance of my to-do service, it could just call to-do service dot underscore find and pass this in, and there would be nothing stopping it, right? So there is no concept of private or encapsulation in JavaScript. But here I'm applying this underscore find convention, this underscore convention to basically say this is a private function. And here I'm calling that function to get an instance of the to-do, right? So when I want to remove a to-do, this takes a to-do, So this is actually weird. You can see here's another, it's not a bug, it works, but this really should be to-do ID. Right, so we can see this find function is taking in a to-do ID. In other words, it's taking in the ID, the number of the to-do, and finding that. So this is, it will work as long as I'm passing in the number here, but it's just poorly named. So we'll get back to that later when we start converting this class. And then this is nothing special. Again, I'm just kind of using the filter function on the arrays, just standard JavaScript array filter function, passing in a function to go and find this. So basically say, find the to-do item whose ID matches the to-do ID that's passed in. For that array that is returned, that filtered array, if I got any, if this length is greater than 0, then return the first one, the first index, otherwise return null. Right, so basically find the first to-do that matches that. And then here again, we've got some AngularJS stuff. I'm just kind of registering this service for dependency injection and all kinds of Angular stuff. So that's the to-do service. That's the main bulk of the app. So with that, let's just get started. I'll kind of go over this other stuff as we get into converting this. But now that we see the to-do service, let's go ahead and get started. So the first thing that we want to do, I'll go ahead and kill this live server. So the first thing that we want to do, I've cloned this GitHub repository to my local machine. The first thing that we're going to want to do is actually install TypeScript. And so we're going to do that by, well, the first thing we're going to want to do is install NPM, Node and NPM. If you're using Visual Studio, the full-blown Visual Studio on Windows, you actually have TypeScript support built right in. But I'm going to be using Visual Studio Code here, which I'll open up in a minute. And Visual Studio Code is actually a cross-platform IDE. So everything that I show here, I happen to be recording this in Windows, and I'm showing a PowerShell get prompt and everything, but it shouldn't matter. You should be able to do exactly what I'm about to do in this video on Windows, on Linux, on Mac, whatever, right? Because I'm using cross-platform tools. And so the cross-platform TypeScript compiler you can get from NPM. So at this point, I've installed Node, I've installed NPM. I'll leave that up as an exercise to you to figure out how to do that. But now the first thing I'm going to want to do is say npm install globally -g, so install globally TSC. So TSC is the TypeScript compiler, TSC TypeScript compiler. And what this is going to do is it's going to go and grab it, it's going to bring it down. I've already installed it actually, so it's not giving me much output, but this is going to link me the TSC executable. Again, in Windows, it'll give me a Windows executable. In Mac or Linux or whatever, it'll give me an executable that I can run there. It's actually a Node executable. And so this is TSC. This is my TypeScript compiler. And so here, it's now a command prompt. So I can pass in some various arguments. And with that in place, I'll open up Visual Studio Code. So I'll just say code and open up this directory in Visual Studio Code, and I'll start converting my project to TypeScript. So we'll start with the TypeScript project. The first thing I'm going to do, just to avoid errors, is I'm actually going to just comment this all out, right? So I'm going to comment this out, and I'm going to start converting it. So as I described before, this TypeScript service, this is the constructor of my class. I don't really have a class, right? Right now, I'm just using kind of prototypical instances to create a service and get a new instance of it and everything. But the first thing I'm going to do is define a class called ToDoService. Actually, the first thing I'm going to do is I'm going to rename this from JS to TS. Right? And then I'll define a class called ToDoService. And then I'm going to copy this in. And this is my constructor. So I'm not going to copy this function ToDoService. What I'm going to do is I'm going to say constructor. Constructor. So that's my keyword. And my constructor is just a method. My method, I don't take in any parameters. And so I paste this in, and immediately you can start seeing that that TypeScript is giving me type information, right? It's saying, you're saying this .todos, but you haven't defined, there's no property to-dos that exist on this type to-do service, right? You haven't defined it yet. Same thing here. There's no to-do service dot underscore underscore ID. It doesn't exist. So let's fix both of those. So we'll start with this, right? So we'll copy this. Basically, we'll re-implement this. So we'll say, since this is a static field, so that's if I just paste it here, this is an instance field. In other words, every time I make a new instance of a to-do service, I'll get a new instance of this underscore underscore ID field or property. And that's not what I want. I want it to be static. So by doing that, you can see immediately the errors go away. So TypeScript says, okay, cool. This is now a static property, right? Not only that, it is a static property of type number. So here's that type inference that I was talking about earlier. I never gave it a type. I never told TypeScript what type this is. Just by assigning it to a number, TypeScript infers the fact that this is a number. And not only that, it says this is a number, and therefore this must be a number, right? If I'm assigning this value to this property of this object, it must be a number. Same thing here. Name must be a string because I'm assigning it to a string. Completed must be a Boolean type, right? Because I've assigned it to a Boolean value. So right out of the gate, I'm already starting to get this typing information, even though I haven't defined any types. So now I've got this transferred over, and we've got this, right? Properties to-dos does not exist on type to-do service. So let's go ahead and add it. In other words, it's saying I don't have a property or a field named to-dos. And if I just define it, right? I haven't defined it as anything. I just say it's something, meaning by default, if I don't give it the type, it's any, right? It's of type any, which again is that dynamic JavaScript type, right? I can do one better. At the very least, I know that it's supposed to be an array, right? So maybe it's an array of any, but at least it's an array. So now I can say it's an array of any right here by giving it a type. And in here, I'm now assigning it to an array, right? So in other words, if I try to assign it to an object, it's not going to let me. It's going to say, nope, this is an array and you're trying to assign it to an object. So it's not going to let me do that, right? So, but because I'm assigning it to an array here, it says everything's cool. That's great. And in fact, I can actually just remove this and move it up here and just assign it right there in line. But I'm going to leave it just, they're functionally equivalent is what I'm saying. But I'm going to leave it in here just because I like it, having it in my constructor. It's just a little bit more obvious that I'm doing it during construction, right? So with all of this, now I can start going over and I can compile this. So I can use the compiler. I can say tsc to-dos service.ts. So compile my TS, and it gives me an error. What is this error? Well, on line 62, cannot find the name Angular. What it's doing is it's referring to this line down here. It says, I have no idea what Angular means. If you'll notice, it generated my JavaScript file anyway. So I'm going to do split screen here from here on out so we can see. It generated it anyway. So it gave me an error. It says I cannot find the name Angular, but it went ahead and generated it anyway. It's saying, okay, I know that you know what you're doing. I trust that you know what you're doing. I'm going to tell you you made an error, but I'm not going to stand in your way. Right? And so using this kind of behavior, this is how you can just kind of start renaming TypeScript files to JavaScript. And so even though TypeScript might yell at you for a lot of things, it will still generally compile with many classes of errors. It'll still generally compile into JavaScript. But at the very least, it's at least warning you, right? It's giving you those errors and it's telling you there are things that are suspect. And then you can start from there. You can start applying the any type just to say, okay, yes, don't worry about that. I am using that as a dynamic type. Or, oh no, I meant, I defined that as a string and now I'm assigning it to a number. I didn't mean to do that. Thanks, TypeScript, right? Thanks for telling me. If we don't want that behavior, if we want to be strict, we can actually add the flag no omit on error. No omit on error, right? So here we can say TSC and then add no omit on error And well, it's not that obvious because I still have the JS file over here. But now if I say no emit on error, and I look in here, the JavaScript file is not created. To-do service.js is not created. Right? In other words, if I remove this, generated, it'll show me the error, but it will generate the to-do service.js anyway. So let's open that back up. And I'm also going to turn on the autosave functionality of Visual Studio Code. So as I type, as I pause, Visual Studio will actually save this stuff. And that we can combine with the TSC. The other option that it has, the other feature that TSC has is the watch function. So I can say TSC to do service watch. So this will actually have a task that sits there and watch, and it says compilation complete, watching for file changes. So now I can go in here and I can add, I can change my file. In other words, I can add, let's add clear completed. Let's copy this one over here. Let's convert this into TypeScript. So as I save that, now we can see it's automatically updating, right? So we've got this watcher and it detected a file change detected, starting incremental compilation. So it's going, and again, it found another error, right? Property remove is not on. And so it's telling me of the error, but it went ahead and compiled it anyway. It said, okay, you know what you're doing, right? But I'm going to go ahead and compile this anyway. So just to make that stop yelling at me, I'm going to copy over these two functions as well. So notice, as I explained earlier, to define a method on a class, so what I had before was function, right? This is kind of the traditional JavaScript way to define a function or a method, but I just remove that and everything's fine, right? So I've got my properties here and I've got my implicit return value. In other words, this and this are exactly functionally equivalent. And you can see over here, as I do all of this and I save, all of this type information is getting stripped out, right? So I have a return value of void on here, and it's just JavaScript over here, so there's no return value, so it just gets stripped out. So now that we have this, everything's going well. We can switch back. We can see, we still got that Angular error, and that's fine. We'll get back to that later. But we're getting more and more, we're getting further along. So let's say that I also want to kind of strip out these comments as I generate this code. Let me kill the watch here and go to TSC, and we see we have the remove comments option, right? The remove comments flag. So we can watch and we can remove comments. And so as TSC goes, now we can see these comments are removed, so it's a little bit cleaner. We're probably going to want to take this rendered JavaScript and run it through another minify or any of those other tools that we traditionally use in our JavaScript tool chain. So none of that stuff is going to change. And so if you want to strip the comments out during that minification process, by all means go ahead. But that's just an option that the TypeScript compiler gives you. All right. So now that we have that, and I showed you how to kind of create a class and add a static property, and these functions, and here we go. Let's revisit this. We've got our private function. It's private, but not really. We can actually make it a little more private, right? We can add the private access modifier on here. And again, as I explained earlier, this doesn't change the rendering, right? If I save this and it re-renders, it's still adding that field, that prototype method, that find_find method on top of prototype. It's still adding it, meaning that if I create a new instance of this in JavaScript and I call ._find, I will be able to access it, right? JavaScript is not keeping me from accessing it. But as I'll show later, if I try and access this _find method in some other TypeScript class or TypeScript file, it will yell at me. It'll give me an error and say that you don't have access to that, right? That's an encapsulated field. That's a private field or a private method. You don't have access to it. You can't use it. So let's get back up here, right? Let's get rid of any, because I used any really just to say this is an array of any object. So in other words, I happen to be adding a bunch of to-dos in here. To-dos being an object that has an ID property, a name property, and a completed property. There's nothing stopping me from adding more objects in here. Right? There's nothing stopping me, and clearly I don't want to do that. Now I've populated this array with a bunch of things that are not to-do items, and in here I'm interacting with them as to-do items. So if we look at here, we've got this IntelliSense for all of these this dot to-do references. These are all an array of any, right? So they're arrays. That's why I'm getting these full IntelliSense of just JavaScript functionality. So here's IntelliSense for the filter functionality, and then I go in here and I get a callback function, right? So I get some IntelliSense here. I get some documentation, some inline documentation. It returns a Boolean. So we're getting a lot of cool features just by using TypeScript, just by adding TypeScript to JavaScript. But if I want to say, well, this is a list of to-dos, right? So in other words, I say to-do. What is a to-do? I have to define a to-do. So I could come up here and I could create a class called to-do. So just like I did a class to-do service, I could create a class to-do. And as we see over here, we get code generated, right? We get a new to-do function and everything. I've got a constructor and all of that stuff. And I can even define fields. So a to-do has an ID field, which is a number, right? It's got a name field. And notice as I type this, as I define things in here, as I define properties and I actually define this type, I'm actually getting errors down here. So this basically says, this is a to-do, this is an array of to-dos, and you've given me an object that has a completed property on there, right? And that's not assignable to the type to-do, right? We can see here, this is not assignable of type to-do because to-do does not have a completed property. Once I add that, there we go. Right? So now everything's fine. Now all of these errors go away and we can see there's actually an issue with this assignment here. So this is yelling at me because now it's saying you're trying to assign things that aren't to-do instances of to-do. Right? In other words, this string, this number, this object. So if I delete those, if I remove those, my errors go away, my code is regenerated, everything's happy. We can see that I'm generating this to-do here, and even though I've given TypeScript information saying I've got these properties on here, I've got the ID and the name is a string and all of this stuff, I'm not actually using them. I'm not using this definition here, right? I'm using them in that I'm setting the properties and everything, but I'm setting them dynamically. I don't have a constructor function or anything, and I never will, quite honestly. So what I like to do is turn this into an interface. So again, an interface is something that TypeScript uses at compile time, at design time, just to give you more information. So it's kind of functionally equivalent of what we just did here, right? We still have a list of to-dos, and to-dos have a name, and if I remove this completed property, I'll get yelled at and all of that stuff, right? But I'm not generating any excess code or additional code that I'm never going to use. Again, if I wanted to actually create a constructor for this to-do instance, and so I could say pass in, the number and a name and stuff, the ID and a name and everything as a constructor, and I actually wanted to write code, to-do would actually have logic and stuff, then yes, I would create a class. But here I don't. I'm just defining a data structure. And when I do that, I will define an interface. Now, a lot of statically typed language, there's a lot of best practices for naming conventions and everything in statically typed languages is whenever you have an interface, you call it I something, I to do, and you can absolutely do that, right? There's nothing stopping you from doing that. That's fine. But for my data structures, I generally like to just call it a to do. Right, so it is the same thing, right? So it just reads better. It's a list of to-dos. It's an array of to-dos, and it just happens to be an interface. It happens to be a data structure, not an object. But that's just me. So now let's go ahead and use this, right? Now that we've got this to-do service defined, let's go ahead and use it. And so in order to do that, let's first consume this clear completed method. So we'll go here and we'll go to this clear completed button. So this is the button. This is, again, forget about all this Angular stuff. This is what we're really interested in, right? So on the click of my button, call this to-do service completed. Where did this come from? Well, it came from here. This is really the only time you need to know about Angular. Basically, just by defining this function and giving it the name to-do service that is registered down here, to-do service and to-do service, Angular will create a new instance and inject it into this function for me. That's the only thing you need to know about Angular for this discussion. Let's just know that this is a to-do service. I get it from somewhere. So let's start by converting this to TS, JS to TS. And it's still going to yell at me because it doesn't know what Angular is. That's fine. It also doesn't know what a to-do service is. So here we can see that to-do service is any. So just because I call my parameter name, the name of my parameter to-do service, that doesn't mean anything. It's just a parameter name. So I can say it is a to-do service, right? It's of type to-do service. TypeScript is going to yell at me. Visual Studio Code is going to yell at me. It's going to say, I don't know what to-do service is. I don't know what that type is. I can't find it. And so to get rid of that, I'm going to add a reference. And I'm going to give it the path to to-do service.ts. So I'm going to say, basically, this is kind of like a header file. Right? Bring this reference of this to-do services in. And all of a sudden, this lights up, right? So, okay, it says, I know this is a class to-do service, right? And so this parameter is of type to-do service. And when I refer to it down here, now I've got IntelliSense. Now it's lighting up here. Property clear complete does not exist on type to-do service. So if I delete this and I say dot, here are the properties that do exist. Clear completed, right? Completed with the D because I had misspelled it, remove, and to-dos. So we will get back to this. I actually don't want this public, right? I want it private. Right now, so let's say clear completed and we'll fix that bug. So that's what I really meant to say. So if I go back, I kill my command line back here and I add this to the list, to-do service and clear completed button.ts. So add that to the list, and now I'm watching both of them. Now we can see clear completed button.ts got generated. What does that look like? Well, it looks exactly the same. It's just some white space stripped out, right? It looks exactly the same, so that's kind of boring. So we'll bring that back to to-do service. And so actually more importantly, I can go back here, I can run my application, and my application now works, right? So I could go back and I could run that. I'm not going to because you could just trust me, but now it works because it's correct, right? This was that error that we saw in the console when I ran my application and I clicked my button. It didn't work because that was misspelled, but now it works, and TypeScript helped me uncover that bug. So let's go back to clear completed. So there's a couple of things I want to do here. So first, let's go back to showing this expression here, right? Getting this reference to the closure. So again, this is an ECMAScript 6 feature. This is not a TypeScript feature, but TypeScript supports it. Instead of saving a reference to this so that we can use it in here, we can simply change this to this, right? Remove this reference, and this will not work as it is right here. This will not work, but TypeScript, ECMAScript 6, and TypeScript give you the option to, instead of saying function X, you can turn this to X and give an arrow. This is called an arrow function or a lambda or a delegate, right? So we say X, parameter X is to do, and we even get IntelliSense here, right? Where did this IntelliSense? Here's a great example of the TypeScript inference. So TypeScript knows that to do. Why does it know it's a to do? Well, because I'm calling the for each function on the array of to-dos. Whoops. Right? I'm calling the for each function on the array of to-dos. And so the callback function will accept a value. And in fact, it can accept a value, an index, a number, an array, blah, blah, blah. Why isn't it requiring me to put an index and an array and everything? It's because those are optional, right? So I just give one, which is a to-do. And then in here, this refers to what you would expect it to, the instance of the to-do service. So then I can just call this .remove, and again, here we go, remove is of any. And so any here, we can get back to that in a little bit, right? But we're passing in that to-do item. So now that we have that, we can apply the same thing here. It doesn't really matter here. It doesn't change anything here. But you could see that as I was compiling this code, as the code was compiling, this got rewritten, right, to effectively what I had before. So here is that delegate in action. So because I referred to this, right, because I referred to this, it actually saved a reference so that my closure would be correct. It rewrote it to that function, just like I had before. It rewrote it, but now TypeScript is taking care of this dereferencing for me. I don't have to do is I can use this this syntactic sugar. Again, I can use this for any method, any function that I want to call. It's just that I don't have to for this one, right? It's just a regular function. I'm using X. I'm just referring to X. I'm not referring to this, so TypeScript doesn't have to worry about it. So it just works. But I can use that anywhere, right? Again, here, change this, save it here, and if we look at the find method down here, TypeScript didn't create an instance of underscore this. It didn't create a reference because I'm not using it. If I were to say and save it, now it sees, TypeScript is smart enough to see, yes, I'm using that reference, so go ahead and create a reference of underscore this so that I can refer to that in my closure. But if I remove it, not used, TypeScript takes it out. So let's jump back to, let's look at this private function again, right? So let's jump back to where I'm actually, whoop, not here. Let's jump back to where I'm actually calling my service here and see that I've got remove and to-dos and everything. So you can see because I marked underscore find as private, I can't see it in this list, right? In other words, if I try to say find, I'm getting IntelliSense, right? I'm getting IntelliSense. TypeScript knows about it, and I can pass in an ID, right? A number ID, but TypeScript is yelling at me. So property underscore find is private and only accessible within class to-do service. So when I save this, TypeScript is going to render this JavaScript out because this is valid JavaScript. This is perfectly legitimate JavaScript. This will run, this will work, but it's not correct. This is where I'm expressing my intent to say, I want this to be private, so yell at me if I ever try to call it as a non-private function, just like I'm doing here, right? So it'll give me that error. Now let's take a look at another field that that also should be protected, and that is this to-dos field, right? So in other words, if I say to-do service.to-dos, I want to protect that. And in fact, you can see down here in the commented out code, I have a method to encapsulate that. So I've got this getAll method on my prototype. So every one of my to-do service instances before I changed this code had a getAll method, and now it just returned the to-dos array. But here is where I basically maintain control over how I'm going to kind of encapsulate or protect this to-dos array. Here I choose to just return the array, but I could clone it, I could make a copy of it, I could make a deep copy, you know, whatever I want to do. But the point is I want it to be a method, right? And so to show this in action, let's go ahead and go to the to-do list. And so we'll change the to-do list from JS to TS. Right, so we'll turn it into TypeScript. And while we're at it, we'll go here and we will add it to our list of files that we're going to watch. And we'll say to-do list.ts. So we'll add that. And so now, even though it is mad at us, right? Even though TypeScript is mad at us and we have some errors, it's still generating the JavaScript. Right, so this is how I mentioned earlier that you can kind of convert. You've got that clear path to convert from TypeScript to JavaScript, basically just by converting your files. And right off the bat, you have some awesome IntelliSense, right? You have that type inference that we've been seeing. But that's not what we're here to show. We're here to show changing this to TypeScript. So I'm going to quickly convert this into a new class, and I'll just go through real quick, and I won't really talk through it much just because you've already seen most of this stuff. I'll create a new class. I will convert this into a static property on that class, and then this becomes my constructor function, right? So I'll just cut this constructor, paste that in. I'll leave that as errors for right now and just continue on. I'll copy these methods over. Remove this, turn them into methods. Okay. All right, so now we've got a couple errors here. Let's talk through these errors real quick. We've seen what these errors are before, right? So basically this is saying you're trying to set a property, but it doesn't exist. I don't know what you're talking about. And so before I showed you to fix it like this, basically, right? So you could say, just assign that, right? And so when we look at this, we can see that we're creating two instances of it, basically. So just by defining it as a property and then assigning it to a value, we're actually, that converts into a constructor call. So this now becomes redundant, right? This is exactly the same. In other words, if I move it up here, it would be exactly the same, literally the same. So I can just remove that reference. And then same thing here, right? I can convert this, I can move this and say, well, I can't exactly move it, right? So I'm going to leave it here, and I will just say to-do service. What's more, I'll give it a type. I'll say to-dos service. It will yell at me because it doesn't know that type, so I'll go here and steal that reference from my button, right? To that reference path to-do service, and I'll tell it about the to-do service TS. As soon as I do that, those errors go away. Furthermore, I'm going to actually say that, well, this to-do service parameter is also a to-do service because that's what I need it to be, right? You can't just pass in a number and I'll assign it to the to-do service. Then everything will blow up. It has to be a to-do service. And so here we can see that I've defined the property and I'm setting the instance and the constructor to the parameter that was passed in. Now, because this is such a popular kind of pattern or a popular thing to do is just take that reference and assign it to a variable, TypeScript actually gives you a shortcut where you can assign or define this encapsulation, this private accessor. So you can say private or even protected. I haven't shown protected yet, but you can do protected, right? And in other words, it's only accessible to this class and any classes that inherit from this class. Private, protected. And what that does, as you can see over here, is it actually assigns it, right? It assigns it to a variable. It assigns it to a value. And so if we remove this, you can see that it removes this redundant one. And so by doing this, it automatically does both, and it's actually still yelling at me, right? It's saying duplicate identifier. Basically, you're creating the same property twice because you're already defining it here in your constructor and you're defining it here. So you can remove this one. And so by adding the accessor, the modifier, by saying private or protected or even public, right? We can use the public modifier. It automatically creates that instance, assigns that property. So I'm going to turn that to private. And so that becomes available throughout my class. So down here we get full IntelliSense, right? So we see this.todo service refers to this underscore to do service. But right now it's saying we don't have a getAll method because the getAll method that I just showed you, the getAll method that I just showed you is down here in our comments. So that's fine. We can copy it, paste it up here, return this .todos. Now that I have this, I want to get rid of it, right? So let's remove this real quick. Now that I have this, I want to get rid of this todos property, right? So I want to call, instead of this, I want to say getAll and call this method in order to get my list of todos. So I'm going to go here and I'm going to apply the same accessor. And I'll say private. And I'll turn that into a private. So now if I come here instead of getAll and say .todos, well, I can't anymore, right? It doesn't exist. If I do it anyway, this will compile. Right, if I save it, we can see that TypeScript has compiled it down. This is legitimate JavaScript. It'll work. In fact, I could run this and it would actually work, right? But it would give me a reference. But TypeScript gives me a different error. Property todos is private and only accessible within class to-do service. Right? So even though this is perfectly legitimate JavaScript, what I'm saying here, here's a perfect example of how I'm expressing my intent, right? I'm saying, even though I don't have true encapsulation, even though this is still getting compiled down to a JavaScript class or a JavaScript prototypical object, basically, right? I want to protect it. I don't want to just expose it to the world. And at the very least, if we're dealing with other TypeScript classes or other TypeScript files that try and access this, at the very least, protect them from accessing it. Yell at them when they try and access it, right? So in other words, we get, geez, I can't find it. In other words, we get this behavior. Still perfectly legitimate, but when I try and access it, it'll yell at me and it'll say, hey, don't do that. It's private. And we change this to get all, and everybody's happy again. We see we still have this error down here. We'll get to that in a little bit. So now that we've got this, we can go and round this out, right? So this will all work, and my to-do list is getting generated, as we can see over here. Everything's generated, everything's fine. So that's fine. So let's go and round this out by just creating add to do. Add to do over here. So we'll rename this add to do JS. We will come down here, we'll kill this, and then add the add to do TS to our watch, which will compile. And there we go. And there's the compiled version. Again, just because TypeScript is yelling at us, we got a bunch of errors on there. That's fine. It gets generated anyway. And then quickly, I'll run through, turn this into class, add to do, constructor, to do service. And in fact, let me just go ahead and copy what I just did here and all of this stuff. Copy this whole thing. I'll call it add to do service. And instead of to-dos, I want to say new task name. And then kill all of that. All right. So I know that was a bunch of magic and copy and paste magic. All I did was just kind of refactor what we had in there before, right? So then we want to add this method, copy the add method. Again, same thing, just create the method. Now, here we're calling add to-dos, right? When I want to add a to-do, in other words, when I go into my website and I type in a name in that input field that we see and I hit enter or click the add button, I want to go and get the new task name. So Angular is handling the binding. If you know Angular, you can see down here I'm using ng model and I'm doing two-way binding to this new task name. In other words, for those of you who don't know Angular, basically anytime I update the value of that text field, this property in my class is getting updated, and then when I click that button or say add, hit enter to add, this method will get triggered, and then I will call this method the to-do service.add, and I will pass in the string, the task name, the string, right? How do I know it's a string? Well, because I define it as a string here, and then TypeScript inferred because my default value is a string. That means it must be a string, right? And because I've defined the to-do service with a private accessor here, then this .to-do service must be a .to-do service, or must be a to-do service, right? But to-do service doesn't have add on there. So let's go ahead and add it, and we'll add it with a string. This will take in a string. If we go down here, I'll copy and paste this, and I believe that's it. So we can kind of delete all of this other stuff. It's the last of it. I'll add this method, and this was that method that I explained earlier where to-do can actually be either a string, accepted as a string, or an object. So in my application, I'm not actually using this overload. I'm not using it as an object, but I want to implement my API to do this, right? Maybe some other application wants to consume this service and whatever reason, right? Let's assume that I have a valid reason to accept both. And I want to make this work. So right now, TypeScript is yelling at me, right? It's saying that you created a new object, and that object had just a name. And that name was to-do, right? The name is any. The type of name, the name property is any, because to-do is any. So I can say, well, no, to-do is a string, right? So that gets that error away. So now name is a string, so that's cool. But now I'm saying, I'm still doing a JavaScript call to check the type checking, right? So unlike Java or C# where you have reflection and you can say is type of blah, 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 you still have to use the JavaScript type of equals object, right? I can't actually say type of to-do equals, to-do service or any of that. I'm saying type of to-do equals object. Now I'm trying to reassign it. And so it's saying type string is not assignable to type name of string. In other words, I already defined this type, the new to-do, as a type. It's a dynamic type. And here we can see it's a type with one property named string. In other words, it's the type that has the same structure as the thing that I just assigned to it. And so here I'm trying to reassign that to a string. That's not cool, right? Even though I'm taking advantage of JavaScript, of the dynamic nature of JavaScript, and I want to do that. So the way that I want to get around this is I want to be able to pass in either of them, either a to-do as a string or a to-do as a to-do. And to do that, I define overloads. So I've defined 3 different overloads. I've really only defined 2 different overloads, right? But it looks like I've defined 3. So here's my actual method definition that says that to-do is any. And so here these errors go away because now to-do can be any, name is any, and we can convert this into a to-do later on. But this will accept either a string or a to-do, right? So we'll come back and fix this in a minute. But for here, we can go and we can actually see we have overrides. So the IntelliSense gives me an override for the string or the to-do. Right? So we can say to-do it can be either a string or an object of to-do. And because this is a string, that's fine. If I were to change this to the letter 1, the number 1, then now I've gotten errors because that's not an overload that it accepts. In other words, even though I've defined this as any, I've defined this and it looks like an overload, this is not an overload. This is just kind of an internal implementation detail to say that basically all of these kind of bubble down, and at this point, the to-do that comes in here can be any. It has to be any because it can be either a string or a to-do, right? But when I go and consume this, we only see 2 overloads, one of 2. It can either be a string or a to-do. It can't be any type. So now I go back in here and I'll come and fix this. So what is it yelling at me in here for? It's saying property ID does not exist on type name any. In other words, going back to the fact that when I assigned this new to-do, I assigned it as this data structure, right? This type, in other words, this type. So this isn't a type that I defined with an interface or a class or anything. This is just an inferred type. So when I created this, it had a name and it had nothing more. So there's a couple of different things I can do to make this go away, right? I can define the ID and I can make it a value, right? A number value. And that makes this one go away. And then I can define it as completed. Right? So that makes those errors go away. But this code may or may not work, right? Because I'm just kind of reassigning it, right? So the other thing I can do is I can say that, hey, you know what? This is a to-do. And it says, no, this is not a to-do because it has a name only, right? So property, you can see the error here, property ID is missing. If I want to get a little bit looser, basically, and say that, well, I don't always need to specify an ID. In other words, that can be optional. So if it has a property called ID, then that property is a number, but it doesn't have to have it, right? So that error goes away. Now I get another one. Property completed is missing, right? Property completed is missing. I can do the same thing here. And I can say, well, you don't need a completed, you don't need a property called completed in order to be a to-do. But if you have a property called completed, it must be a Boolean, right? In other words, I still get this type checking down here where if I say completed equals 12 or 1, 2, 3, nope, no good. Not assignable because completed is not compatible, right? It's a number. It's not a Boolean. So we still get that type checking. We still are limited in the values that we can pass, but now we've made them optional by adding that question mark and saying, well, you can add them if you want to, but you don't have to. And so now this code works. If we want to go down in here and now we say, well, if it's an object, then assume that object is a to-do. We can very explicitly say that. We can cast that. The reason it wasn't giving me an error before is because to-do is actually any. And so we can always cast implicitly. We don't have to explicitly cast from any type to a specific type, right? Because any can be any type, including the type that we want it to be, right? So TypeScript will never yell at you if you take an any type and assign it to a specific type, because that should just work. In other words, it can't protect you. So basically, in other words, doing this is just simply redundant, right? TypeScript's doing that anyway. Now, if I wanted to do this, you know, that'll work. Or if I want to do this, right? Here's a good example of casting this, very explicitly casting this to a to-do. But that's not what I want to do. I want to add to-do. There we go. And so now that's my fully completed application. So if I go back here, we can see that everything is working again. I've now successfully converted add to do, clear completed, to-do list, to-do service. Everything should be good. If I go back through here, I shouldn't have any commented stuff anymore because I've converted everything over. We can see I still have my errors that it doesn't know about Angular. We'll solve that in 1 second. But now that I've got all of this, let's go ahead and try and run that application again. So we'll go ahead and kill this TypeScript watch. And I'll run my live server. Live server again is just this is just an npm package, a node package that just gives me a basic web server that I can run. So you don't have to use live server. You can use any web server you want. But there we go. So now not only does this work, and I can add a new task. Now I can clear completed because TypeScript has helped me find that bug. Why didn't it clear completed? I don't know because I got a bug in there, but that's fine. Let's go and look and see why that didn't work. So here's a bug that TypeScript did not help me remove. Oh, no. Okay. Great. So now that we've got that, now let's go and okay, rephrase. All right, so now that we've got that, let's move on to the next step and look at how we can actually get some definition files for external libraries, right? So rarely do you ever create an application where you're creating all of the code, right? So here we've got in my to-do list and all my other classes, right? I've got references. I've got reference to the to-do service. So in order to consume that to-do service and learn about it, I have to add a reference to it. And we're getting errors all over the place because we have references to Angular, which are working. They're correct, right? You've seen the application working. But Angular doesn't know about it, but TypeScript doesn't know about it. So in order to let TypeScript know about it, we're going to add something called a TypeScript definition file. And there's a very cool project on GitHub . And there's a very cool project on GitHub called Definitely Typed. And so this project has, and you can see, sorry, we had to truncate this directory to 1,000 files. So this GitHub project has TypeScript definitions for pretty much any open source library that you want to use. So if we scroll up here, we saw here's Angular 2 or Angular JS. Right, so here are the TypeScript definitions. We have .d.ts, angular.d.ts. And if we go into here, we can see these are not the full implementations of Angular, right? These aren't the full implementations of these open source libraries. These are simply the definitions. They define the libraries. They define the interfaces, right? So they define interfaces. You'll see declare modules. So they're creating modules. Here's that module again. Interface, interface, interface. So they basically, and here's some comments, right? So they basically just define, these are like the header files. So if you've used C# or if you've used C++ or anything like that, that has header files, these are basically, they just define the structure of the things that you're working with. They don't actually implement the things you're working with. So in other words, I'm going to still get angular.js as I'm doing here, right? I'm still going to need to link to that here. So I'm still going to need to pull in AngularJS for my application to actually work. But in order to give TypeScript what it needs, the information it needs to work with Angular, I'm going to import this definition file. And the way that I'm going to do that is with another tool. This is the TSD tool. So there's a tool called TSD that just goes and basically it interacts with this definitely typed project, and it pulls down just the project that you need, just the TSD file that you need, right? So in other words, we have definitely typed and indefinitely typed. We have hundreds, we saw them earlier, hundreds, thousands of open source projects, but I don't want to pull down this whole GitHub repository just to get AngularJS, right? So in other words, I just want AngularJS. I'm not going to pull down the whole GitHub repository. What this TSD tool allows me to do is just pull down the TypeScript definition that I need. So the first thing I'm going to do is npm install TSD. Right, so I'm going to install the TSD npm package as a global. I did -g just to install it globally, so I'll have it everywhere. So now that it gets installed, I can say TSD query, right? So I can search for things. I can say TSD query Angular. Let's see what happens if I search for just Angular. It found AngularJS/Angular. And now I can install. So I can say TSD install Angular. And so what this will do is it'll actually go and download those files, and it has copied actually angular.d.ts. So this is that same definition file that we just saw. And it will also grab any dependencies. So Angular is dependent on jQuery. Not technically, not literally, but most of the time when you're bringing down Angular, you're also bringing down jQuery. So the TSD file handles that dependency as well. And so we saw over here, actually I could just show you in here, right? It adds this typings folder. So in typings, we've now got two folders, AngularJS and jQuery, and we can see the definition file. Now there's also an overload to TSD. So if we look at TSD, it's got a whole bunch of stuff. One of these things actually allows you to save, right? So you can save changes to a config file. So if we say TSD install Angular and then save it, not only will it create it, it'll also create a TSD. So in the typings folder, it'll create tsd.d.ts. And so if we go in here, it'll actually create two files. So it'll create tsd.json and then tsd.d.ts in the typings folder, right? So tsd.json is just some configuration files, right? So this shows me what GitHub repo I got it from and which bundle and which version. So this is the commit hash of the GitHub commit that we used. And then it'll also give me tsd.ts. So with this, now I can add this reference, and this automatically, this is just a list of references to these various TSD files that I've installed. But when I want to reference these things, I can just add a reference to tsd.d.ts, and it'll automatically reference jQuery and Angular and everything. So in other words, I can do this. I can go to to-do service, and I can scroll up here, and I can add a reference to typings, AngularJS, blah, 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 blah. Or I can add a reference to the TSD file, which will automatically bring in the references to Angular. So now when I scroll down here, you can see I've now it knows what Angular is. Angular is ng.iAngularStatic. That's the type of it. And when I do that, now I've got full IntelliSense here. So off of Angular, I've got bind, I've got bootstrap, I've got for each, I've got module, right? All of this stuff. And then if I go in here, I can get full IntelliSense for module. So module has a name that's a string, requires an array of things, blah, 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 right? Module, the name, the parameter name, the name of the module to create or retrieve. So here now I've got full IntelliSense on a third-party library. On Angular. And so here's a really cool usage of it. If I copy this and I bring it over to my button. So for those of you who have used Angular and are familiar with Angular, now I always forget the what I need to return in a directive, right? So if you're unfamiliar with Angular, directive is just a function that returns a property, and the property is the thing that defines the directive. It's just an object that defines the directive. So now I can actually say ng iDirective, and now I can get full IntelliSense on this directive, right? So I can see what all these properties are on this object. Now I've gotten rid of all of those errors that refer to Angular, and I've got full IntelliSense on Angular. So here's look at this full documentation, right? So this is that inline documentation we just saw in the TSD file. The Angular module is a global place for blah, 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 blah. So this is documentation that's coming from that TSD file. But now I've also still got references to this to-do service, TS, right? I shouldn't have to reference that everywhere, right? It's in my project, and everybody should just know about it. Likewise, I have been going down here, and I've been adding this big, long watch function, right? This TSC, this compilation thing, and I've added every individual file. And this can get really painful. When what I really want to do is something like tsc.dot. Right, just compile everything in this folder, or tsc star.ts, right? Just compile everything. This isn't working. It might not be obvious just because there's no output. It's not yelling at me. It's not giving me an error, but this isn't working. So the way that I can make this work, let me go through and remove all of this. All of these references, let me just change them with references to typings. So we'll make the Angular references work, and we'll take away the references to to-do service. So now we go here and we add a file called tsconfig.json. And this is a configuration file where we add all of our configuration properties for our TypeScript compilation. So just by having this file in this folder now gives me a whole bunch of defaults, right? So now if I just add this and then I say tsc, it'll actually read from this tsconfig file. And now we can see that these things are getting updated, right? So now simply by adding this file, I didn't even add anything in this file. I just had an empty configuration. Now by adding things in this file, this kind of turns the project into, it turns the folder into a project. So now all these files kind of know about each other, right? I still have these references to the TSD file just to be very specific, but now at the very least, the to-do lists, right? Everybody knows what a to-do service is. And likewise, if I were to access to-do list in some other class, it would know about it, like simply because it's in this folder, right? So with this, there are some configuration settings that we can kind of put in there. And what are those configuration settings? Well, frankly, I always have to look them up. So we can just do tsconfig.json. We'll look this up, and we'll go to the TypeScript wiki, the TypeScript GitHub site. So on here, we've got a whole bunch of stuff, right? So we can set these compiler options. So these are going to be the first things that you're going to want to set. So these compiler options are basically the options that we saw from the command line, right? So in other words, we say tsc.help, and we have all these command line options: preserve const enums, remove comments, source map, all of this stuff, watch, right? All of this stuff kind of translates into examples over here. So in compiler options, we can say compile to the module common.js. What target do we want to target, right? Let's say what target, ES3. So we can do different targets. So we can target ES6, we can target ES5, we can target ES3. So what this means, what target means, is what version of ECMAScript do we want to render out, right? So this will actually change what JavaScript is transpiled. So the default is ES3. I don't know why we'd want that. That's really old browsers. So really ES5 is kind of the safest. That's what we've been using. That's been the default that I've been showing. Here, otherwise, I'm saying remove comments, no implicit any, all this stuff. Let me just remove these other ones. And I'll get back to source map and everything in a second. But if we do this, if we save this, and we go back to, let's open up the to-do service. And we see this, and now we can say TSC watch. So I no longer need to pass in a whole long list of file names. It'll just read off of my configuration file, and it'll turn the whole thing into a project. And we notice when I did that, we just generated a whole bunch of source maps. So like I said, I'll get back to those in a second, but the reason those were generated is because of this source map true. And I'm removing comments, right? We see the comments are removed. But here we go. We're looking at target ES5. So now if I take this turn from ES5 and ES6 and I change it to ES6, the difference is that we no longer have to convert these arrow functions, right? We see X completed and this dot remove, these arrow functions. So the difference is that ECMAScript 6 actually natively supports things like the class keyword. It supports classes. It supports constructors. It supports methods on classes, obviously, because it supports classes. It supports the arrow functions that I showed earlier. Right? So no longer do I need ES5 no longer do I need these shims, like saving a reference to underscore this so I can pass it into this function, because ECMAScript 6 and the browsers that understand ECMAScript 6 automatically understand the arrow functions, and they automatically understand classes, right? So here is where TypeScript becomes helpful when you're kind of developing for the future. So you can say you can develop future JavaScript code now. You can develop in ES6 code right now, and then when you compile that, you can change the target to ES6 and just compile out to ES6 later on once ES6 is actually supported in the mainstream browsers that you're supporting. So now back to this source mapping. So source mapping is a pretty cool feature, right? So this is actually not a TypeScript feature. This is actually a browser-based feature for any of these transpiled languages. What this enables is it enables me to go in. Let me change this back to ES5 real quick. So we've still got that source mapping URL. So when we say source map equals true, when TypeScript generates the JavaScript code, it'll add this line at the end here, this little directive that says source mapping URL equals todoservice.js.map. So that's referring to this file. This is the mapping file. This is a cryptic file, and that's fine if you don't understand it because you're not supposed to. The consumer of this file is the browser. So this is very specifically to support browser debugging in any transpiled language. So, CoffeeScript, Clojure, or whatever language, whatever other language that you can use that will compile down into JavaScript that will run into the browser, you can generate these source maps. And what will happen is when you run this in a browser, so if I run my live server again, and I execute this, I can go in and I can get full native debugging. So if I go to sources and I pick any of these files that have a source map file, I can now see the actual TS file here, the TypeScript file, right? So this is my native TypeScript file. So you can see all the TypeScript stuff. It's even more impressive if you do something like to-do service. And I go in here, look at this, I've got my overloads and everything. And so now I can actually set a debugger in my TypeScript file. Let's do it in a clear completed here. And now I can trigger this and I actually get a breakpoint in my TypeScript file, in my TypeScript code. And not only do I get a debug point, I get full IntelliSense, right? I get full kind of debugging, I get the full call stack and everything. Now I can actually go through and I can step through and debug, right? I can F10, F11, F10 to step over, F11 to step in. So check that out. I just stepped into to this function, right? And so I can set my watches and I can add X, right? I can see the value of X and all of this stuff. I can step out, Shift F11. I've got full debugging capability right there in the browser. Hit F5, continue on. There we go. So that is source mapping. So the goal of this session, the goal of this presentation was really just to kind of get you up and running with TypeScript, explore the fundamentals, kind of the 80% cases that you're going to need, right, in order to start working with TypeScript, and just really get you up and running. And so if you're interested in learning more, you can check out my GitHub site. It's on my GitHub site, github.com/jchadwick/TypeScript intro. You can check out more information on TypeScript at typescriptlang.org. So again, my name is Jess Chadwick. My email, jesschadwick@gmail.com. Please feel free to touch base with me, reach out with any questions or concerns or comments, or just leave comments in the comments section on this page. I'd love to hear from you. Thank you for your time. I hope this has been valuable to you, and have fun with TypeScript.